Hey guys, tonight we're going to do a topic called multiplication and division of complex numbers. So multiplication of complex numbers. And these are going to be in polar form. And remember, polar form can also be called trig form. So we're going to have two complex numbers. So here's the complex numbers. The complex number is going to be, the first one is going to be called Z1. So subscript 1, so Z1 equals R1 cosine theta, but we're going to call it theta 1 because we're going to differentiate this from a different number. So it would be cosine theta 1 plus I sine theta 1. And the other one, Z2, think about it, and it's going to be R2 cosine theta 2 plus I sine theta 2. So these are our two numbers, and what we're going to do is we're going to do the multiplication division. So we'll start with multiplying. And here's our formula that we're going to do. Z1 times Z2. Now remember, R is the modulus, so this is the moduli. So R1 times R2. So you multiply the modulus, and you're going to add the angles. Cosine theta 1 plus theta 2. And put these in parentheses, plus I sine theta 1 plus theta 2. So we're going to use our textbook. So it'll be textbook, page 559. And we're going to do two problems for multiplying. So this is question 19 in your book. So they say Z1 equals 7 times cosine of 25 plus I sine 25. And Z2 is 2 cosine 130 plus I sine 130. Follow this pattern. When you get done, it's going to be still in the form Z equals R1 cosine theta 1 plus I sine, or not 1 though, it would be Z equals R times cosine theta plus I sine theta. So take these two things and see what you come up with. Alright, so hopefully you multiply 7 times 2 is 14. Let's change color here. So 14 times cosine, add the angles, and this is all you got to do. 135 plus, not 135, excuse me, 155 plus I sine 155. And that's the complex number in polar form. So let's try it again. So this is question 21. And this time it'll be in radians, so I want my answer in radians. So Z1 is 5 cosine pi over 4 plus I sine pi over 4. And Z2 is cosine 5 pi over 3. 3 cosine 5 pi over 3 plus I sine 5 pi over 3. All right, so why don't you try this one? So this would be our new, you're going to multiply the r's, and you're going to add. You need a common denominator. If you have an issue, use a calculator. You're going to leave your answer in terms of pi, though. Don't leave it in degrees. They gave us radians. We're going to get back radians. Try it. Five times 3 is 15. Now, let's think about this. So I got to make this 12s. So this would be multiply top and bottom by 3. So this is really 3 pi over 12. And this guy down here, I would multiply. So that would make 20 pi over 12. Okay. So let's Let's try this. So outside 5 times 3 is 15. And I'm going to add the two angles. So it'll be cosine of 20 pi, 23 pi over 12. Add the angles. Plus I sine 23 pi over 12. And that's how we multiply. Let's try some division. So for division, so let's write a little note, and we have a formula. So for division, all right, very similar. So z1 over z2. Now when I multiplied the r's and added the thetas. So what should we do with the r's and the thetas? Well, I'll divide the r's, and instead of adding, we subtract the thetas. So cosine theta 1 minus theta 2 plus I sine theta 1 minus theta 2. So once again, same page, page 559. And let's try two problems. So 23. What does it say? 2 times cosine 30 plus I sine 30. And the real way you should say that would be 2 times the quantity, cosine 30 plus I sine 30, over 3 times the quantity, cosine 30, how much is this one? 60, cosine 60, I sine 60. Okay, so this one's going to have fractions. I'm not going to worry about it. So nice and easy, nice and easy. Okay, so we're going to divide the front. So 2 over 3, just leave it as 2 over 3. And subtract the angles. Now 30 minus 60 is negative 30 plus I sine negative 30. All right, now I'm not a fan of this negative 30 degrees. So let's think about this a second. Negative 30 would be down here. That's negative 30. So that's quadrant 4. So in quadrant 4, it would still be positive cosine. So I'll keep the 2/3 cosine 30 plus, now in quadrant 4 it would be negative, right? So the equivalent, you remember like when we did it, it would be expressed as a positive acute angle. This is exactly what that is. So instead of saying plus, I move the minus out there because I'm in quadrant 4. So not to worry, not to worry. Minus I sine 30. That's the first one. Let's do an easier one. 24. 6 over 3 times, oopsie daisy. I'll put it all together. All right, let's try that again. Fraction. So 6 upstairs, cosine 5 pi plus I sine 5 pi. Now remember, since these are in polar form, these the front angle and the back angle must match in your equation. And downstairs is 2 pi's. So cosine 2 pi plus I sine 2 pi. All right, so let's try this. So I want you to try it out and see what you get. Try it out and see what you get. So 6 divided by 3 is 2. Here's my setup. Cosine 5 subtract 2 is 3 pi's plus I sine 3 pi. Now, all right, hold on now. It's kind of similar to this other thing here. So if I talk about this pi thing going on, it's from our, remember, I like to think of a unit circle. So that's 0, and then pi, 2 pi. So 3 pi winds up back over here at 180 degrees. So I'm going to, instead of saying 3 pi, I'm just going to call it pi. So this would be 2 cosine pi, because usually it'll say from 0 to 2 pi or something like that, plus I sine pi. Now, I'm not going to put the negative in here because we didn't actually evaluate this function here. So I can, pi is positive. I mean, I don't have to worry about that part. So it's from 0 to 2 pi, so that's good. Now, on the other one, I had to change it because the negative 30 was a negative angle. So that's why the negative moved out. So this one is done. And if you actually crunched it out, you would get like a number, complex number. Might have the I, might not have the I. And it would be the same thing as if you typed it in a calculator or converted them first to complex and then did the multiplication and division. All right, that's it. Have a nice night.